So this is now no longer limits approaching a number. You're approaching infinity. So if you think about a graph and you're approaching infinity on it, let me just find a picture of a graph. I'm going to draw one. Let me just give you a graph. I'll give you a piecewise graph just for fun. If they ask you for the limit as your x-coordinate is approaching infinity, which way are we going here? To the right. When we are dealing with limits as x approaches infinity, or as x approaches negative infinity, it's really just talking about end behavior, is what you called that last year. What is the graph's end behavior doing? Right. So this particular one, limit as x approaches infinity, on this particular graph, as my x-coordinate increases, what's happening to my y-coordinate? Increases towards infinity. Yes? Last year you did do this, not a lot last year, but there were definitely some Regents questions that said as x approaches infinity, f of x is approaching infinity. And that was how you kind of established end behavior. It's the same idea. And then likewise, if I do, what is the limit of this as x approaches negative infinity? As my x-coordinates get smaller and smaller and smaller, what's happening to my y-coordinates? My x-coordinates are, right, but it's like end behavior though. So anything can happen in between, I don't care. It's like, what is the end behavior? It's ending towards positive infinity also. Yes? So when we talk about limits as you go towards infinity, we are talking about end behavior. Okie doke? Okay. Yeah, you're not going to want to take this quiz tomorrow. It is if you're shown a picture, it's easy. But these are not pictures. These are graphs, and you have to know what the graphs look like.
Are we not allowed to use a calculator? 5 points.
What?
Oh, let's see here. You'll be allowed to use your calculator, but there's something else. There's other questions that can be asked that you need to know how to do. So, this I don't know if you know or not. I don't think my Algebra 2s would know this, but on rational functions, so not linear. Linear is pretty straightforward. You guys know what 8x looks like, right? It's a graph that looks like this. So as my x-coordinates approach infinity, so going to the right, to the right, to the right, what is happening to my y-coordinate? Infinity. So linears I'm not worried about. Everything else on here is rational though. And there's a set of rules with rationals that you don't know. And rational graphs, you know this about a parent graph. Rational parent graphs, which is just 1 over x, looks like this. They have horizontal asymptotes. And what horizontal asymptotes do is they guide end behavior. So wherever your horizontal asymptote is, that is your behavior as you approach infinity or as you approach negative infinity. So for example, this parent graph has a horizontal asymptote right there. Do you remember that from last year? Okay. As my x's go towards infinity, so I go right, 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 what's happening to my y-coordinate? It's getting closer to 0. That's because my horizontal asymptote is y equals 0. Do you follow? Horizontal asymptotes guide end behavior. So on a parent graph of rational, that's always at 0, but the horizontal asymptotes are not always at 0, and there's 3 scenarios. And this is what you will be brand new to you. The location of your horizontal asymptote comes from an evaluation of the power of the numerator as it compares to the power of the denominator. So, or when I say power, I mean degree, right? Degree means the biggest exponent. Yes? So in the parent graph, this is technically a degree of 1, x to the first. And any constant technically has a degree of 0. So that would be a degree of 0 over a degree of 1. That is what I would classify as small over big. The numerator's degree is smaller than the denominator's. And anytime it's a small over big, which is which case here, the power of the numerator is less than the power of the denominator. That to me is small over big. In that case, your horizontal asymptote is 0. So whether you're going towards infinity or negative infinity, your graph is getting closer and closer to 0. You can see that on your parent graph. As we go towards positive infinity, it's shrinking down towards 0. As you go towards negative infinity, it's kind of increasing towards 0. But they're both going towards 0. Follow? Faith. Oh yeah, we already did that this year. Yes, you did already do these rules. We're going to review. So if you, I'll pretend like we've not, that's right, we did them. Okay. I did it. When we graphed rational functions, we looked at horizontal asymptotes. And I believe, Ryan, yes, that is when I pulled your calculators from you. Okay. Well, I haven't crossed that bridge yet here, so hold on.
Is it reference of like the saddle and the horses?
Okay.
About a horse without a saddle?
So if it's...
Still wrong.
This one is what I call same over same. If the power of your numerator is equal to the power of your denominator, so like, yeah, we'll look at number 1 right after this, same over same, then your horizontal asymptote comes from the leading coefficient of the numerator divided by the leading coefficient of the denominator. So, as Tommy said, look at number 1. Number 1 has a degree of 2 up top, and the coefficient is positive 1 on that, and a degree of 2 on the bottom with a coefficient of 3. So, same over same, x squared over x squared, you pull the coefficients, and your horizontal asymptote is 1/3. That means your end behavior, whether you're going towards infinity or negative infinity, the limit is 1/3. It's either going to be shrinking towards 1/3 or increasing towards 1/3. It's getting closer and closer and closer to 1/3 as you go towards infinity.
Well, like, do you know what I'm saying? Like,
No, I don't know. Like
you're not
calculation.
really doing, I don't know, like, you're just
Yeah, it seems too good to be true.
yeah, like,
Oh, so this is easy. Good. So let me show you what this graph looks like. X squared plus 2x plus 3. So if I just show you this graph, it's going to be hard to see your horizontal asymptote right here because that's a really funky graph, number 1. But number 2, you see that it's flattening out as you go towards infinity, and you see that it's flattening out as you go towards negative infinity. It's just hard to see that that's at 1/3 because we're so pinched in. We're going from negative 10 to 10. But if I look at my table and I go back towards negative infinity, what's happening to these numbers? You can't really see. I'll tell you, it's like 0.3007, 0.3021, 0.3054. If I keep going, it's going to approach 0.3333333333, which is 1/3. Yes? And likewise, if I set up my table and let me say I'll start it at 100, which is not even close to positive infinity, but it's a high number, our numbers are 0.3412. As I get higher and higher, it's decreasing. Do you see it? 3, 4, now we're into the 3 3s. It's only going to decrease to 0.3333333333, and then eventually the calculator only goes out 4 decimal places. It's probably technically 0.33335, and then 0.33334, and then, but it's just, and when they run out of 0.33334, they'll go down to 0.3333339 again. Like they'll just add another 3. So it's just, the point is, you can see it shrinking a little bit better, and you can see why that 1/3 actually, that we calculated algebraically, made sense. Follow? Okay. And then the last one, when it's big over small, power of the numerator greater than power of the denominator, that to me is more confusing. I just think big over small looks so much easier to remember. That is not going to have a horizontal coefficient or horizontal asymptote. No horizontal asymptote. And if you have no horizontal asymptote, that means you're not flattening out as part of your end behavior. Rather than flattening out, you're either going to go towards infinity or negative infinity. So this is a little misleading. The limit is not equal to infinity necessarily. It's either infinity or negative infinity. And you have to kind of figure that out for yourself. And I'll show you how to do that. Does anyone see a big over small? 4. Okay? So 4 is definitely a big over small. And I'm going to rewrite this. Negative x squared plus 100 and x plus 10. Okay? We talked about slant asymptotes, yes? Okay? We needed to do long division to figure out where those were. We could still do that. We're not going to fully do out the long division, but we are going to consider if I divided this out, what would my leading term be? Negative, what's x squared divided by x? X to the first power, dot, dot, dot. The point is, that's an odd degree polynomial, right, with a negative coefficient. And based on your end behavior from last year, a negative odd starts high, ends low, correct? Remember that? It's not going to work, is it? 10 minus x, 10 plus x. Well, so factoring and canceling is essentially division. It's not going to always work, though, but you can. So just from last year, here were your 4 categories. Positive, negative, and that's talking about the leading coefficient. And then there was even and odd, right? Even is like quadratics. If it's a positive quadratic, it starts high, ends high. If it's a negative even, it starts low, ends low. Yes? If it's odd positive, it started low, ended high, had an overall positive slope, and this is like a line. Lines are odd, technically have a degree of 1. And if it's a negative line, it starts high, ends low. So if you're asked about the limit as you approach infinity on a positive even, it's infinity. Yes? If you were asked for what is your limit as you approach infinity on something like this, as you approach infinity, your y-coordinate goes down towards negative infinity. So once you consider what would happen if I divided these out, and this one is a negative x to the first power, that's something that has this end behavior. So now we can base our answer off of this graph alone. So as the x-coordinate goes towards infinity, and I go right, what's my y-coordinate doing? Negative infinity. And so that's your answer. Is there another big over small? 6 is same over same. Because you're looking at the coefficients versus the degree. Okay, number 5. So if I take a 3x cubed and divide it by a 3x squared, there's no horizontal asymptote because it's big over small. But if I were to do the division, I would get a 1x with some extra stuff. What degree is that, even or odd? It's x to the first power, so it's odd. And is it positive or negative? Positive. So a positive odd starts low, ends high. So we kind of visualize a graph like this, and as x approaches infinity, so as I move to the right, what's happening to my y-coordinate? Infinity. Good, Greg. So jump down to 9. There's another big over small. And we're still approaching infinity. So big over small, no horizontal asymptote. So you think about, if I were to do the division, what would that give me? And it's a positive. Positive x. So again, that starts low, ends high. So as x is approaching infinity, what's my y coordinate doing? Good. Let's do 11. 11's a good one. So, and I pick 11 because they all keep dividing out to something to the first power, which is not always the case, like in 11. Your leading term is 8x to the fourth, and in the bottom it should technically be negative 4x. So that's big over small, agreed? So when you divide that, what would you get as your leading term? Negative 2x cubed. So that's still even or odd degree. Odd degree with a negative out in front. So odd degree with a negative out in front starts high, ends low. So now we can use that graph. As my x's go towards infinity, meaning as I move to the right, what happens to my y coordinates? Negative infinity. Good. I don't know. I don't know if everyone thinks that. Right. Well, let's quickly do some of these other ones. I don't want to take these for granted. But small over big, what's your asymptote? 0. So your answer is just 0. Got it? This is same over same. So what's your asymptote? Coefficients, which would leave you at 3. Let me explain that, Mike. Same over same means your coefficient comes from, or your asymptote comes from the leading coefficient divided by the leading coefficient, which is 6 divided by 2. So if your horizontal asymptote is at 3, then that's guiding your end behavior, whether you're going towards infinity or negative infinity, so that answer is 3. Yes? Maddie, what would you say about your degree here? Small over big, big over small, or same over same? Small over big, so what's your asymptote? 0, so 0 is your limit answer. As you go towards infinity only. That's not going to be the rule if x is approaching 7, right? If x is approaching 7, you're just going to plug in 7. You follow? Okay. And what's the rule here? Same over same. So the ratio of the leading coefficients, Bean, what do you think here? I didn't ask you. I asked Bean. Don't listen to him. He's wrong. What's the leading coefficient of the top? What's the leading coefficient of the bottom? Negative 6. Negative 1. So you tell me, are we, and well, maybe you need your homework before you can make that judgment.
I'm saying we get
Easy buckets.
Raise your hand if you think you want to take this tomorrow and get it over with.
I haven't been ready for a test like after.
10 of you. Raise your hand if you think you need to wait till Monday. Sorry, Brock. All right. If you think you're ready and you prefer it, we'll do it tomorrow. So I'm going to give you the limits with infinity. This is your actual homework, the odds. The review sheet is just for your benefit. On the review sheet, you're going to find a mixture of approaching numbers and approaching infinities. With the numbers, you just plug them in.
We just need to memorize our NVD.
If you need to freshen up on that. And that's only going to apply, though, when it's big over small. When it's big over small and infinity. Coefficients. Yep, that's the summary right there. Good? All right, so your homework says limits with infinity. You're doing the odds. Your review sheet, which is optional just for you to wrap your head around it. We can start class tomorrow with like 10 minutes worth of questions if we need.
Is it like
I don't know, Brock. I have to make it. I don't want to make it long. There you go.
It's like, oh, it's like 7160, yeah?
Oh, like at the end of Polish last names ski. I thought it was like downhill ski.
Yeah. How about that?
I should have grown
Wouldn't
that.
it be too icy? I don't know.
It said skiing.
Oh, yeah.